Welcome to all of you. My name is Dr. Neha Desai from Department of Chemistry, RBNB College, Shri Rampur. Now we will begin with the new topic from the section number 2 of paper number 3 CHA 392, that is HPLC method. In the topic HPLC method, there are 5 subtopics, or we will discuss the 5 subtopics in HPLC method. What are these subtopics? The first one is the adsorption chromatography. The second one is the reverse phase chromatography. The third one is the chromatography with chemically bonded phase. Then fourth one is the ion exchange method chromatography. And the last one is ion pair chromatography. So this topic HPLC method is subdivided into 5 main points. That is, we will discuss about the adsorption chromatography or the normal phase chromatography, then reverse phase chromatography, then the third one is the chromatography with a chemically bonded phase, fourth one is the ion exchange chromatography, and the fifth one is the ion pair chromatography. So there are many sub points under each heading. So to begin with, today we will start with the adsorption chromatography, or it is also known as the normal phase chromatography. Before starting the actual discussion part, we will start with the syllabus. So we will discuss what is the syllabus for the adsorption chromatography. In case of adsorption chromatography, which is also known as normal phase chromatography. So in this case, we will begin our discussion by what is meant by adsorption, or what is adsorption. This is the first point. Then the second point from the syllabus is the heliotropic series. Then the further point from the syllabus is the selectivity and properties of the mobile phase. Now, the fourth point is the choice and optimization of the mobile phase. and lastly we will discuss about the applications. So as far as the syllabus of the adsorption chromatography is concerned, we will begin our discussion with what is meant by the adsorption. Then we will discuss about the heliotropic series. Then we will study the selectivity and the properties of the mobile phase, and after that we will study the choice and optimization of the mobile phase, and with the application part our first subtopic, that is adsorption chromatography, ends. So the first topic is what is meant by adsorption. So, to start the discussion, adsorption chromatography is based on the principle of adsorption. Means here the separation of a mixture into different components is carried out by using the principle of adsorption. Before that, it is very necessary to understand the difference between the absorption and the adsorption. So, as all of you know that adsorption, it is a surface phenomena. While absorption, it is not a surface phenomena. In case of adsorption chromatography, you have to concentrate yourself on the adsorbate-adsorbent interaction. So what is the result of the interaction between the adsorbate and adsorbent? Depending on that, the separation of the analyte takes place in case of adsorption chromatography. The HPLC methods are basically divided into the two types. The first one is the normal phase HPLC and the second one is the reverse phase HPLC. So as far as the adsorption chromatography is concerned, it is also known as the normal phase HPLC. Now, what is the main difference between the normal phase and reverse phase HPLC? That is, in case of normal phase HPLC, the stationary phase is hydrophilic while the mobile phase is hydrophobic, and in case of reverse phase HPLC, vice versa is the case. So, as far as normal phase HPLC is concerned, the stationary phase is hydrophilic while the mobile phase is hydrophobic. Before that, what is the meaning of the words hydrophilic and hydrophobic? Hydrophilic means water loving molecules, while hydrophobic means water hating molecule. Whenever you are using a HPLC technique in which the stationary phase is hydrophilic and the mobile phase is hydrophobic, so at that time you will call it as a normal phase HPLC. So the adsorption chromatography is nothing but you are dealing with the normal phase HPLC technique. Now coming to our original part, that is the discussion of the adsorption. So now all of you know that the adsorption chromatography works on the principle of adsorption. Here the separation of a components from a mixture is carried out by using the principle of adsorption, and hence the name given is the adsorption chromatography. So for that, what is the most necessary step? That is, you have to consider the interaction between the adsorbate and the adsorbent. So what is meaning of the word adsorbate? Adsorbate is the surface on which adsorption takes place. While adsorbent means your molecule of interest. As all of you know that the adsorption is a surface phenomena, you have to consider the interaction between the adsorbate and the adsorbent in the adsorption chromatography. So the surface, it is nothing but the adsorbate, and the adsorbent means the molecule of interest which gets adsorbed on the adsorbate. So when this interaction is stronger one, what will happen, and when this interaction is weaker one, what will happen? This is the case for the adsorption chromatography. When the adsorbate-adsorbent interaction is the stronger one, then your molecule is adsorbed on the surface very strongly, and therefore it will take more time for the separation, or we can say for the elution purpose. Now these adsorbate-adsorbent interaction, they depend on number of factors. So which are these factors we will study. So the efficiency of separation by using the adsorption chromatography mainly depends on the adsorbate-adsorbent interaction, and these interactions mainly depends on the following factors. The first factor is the solubility of the molecule in the mobile phase. So the first factor is the solubility of your molecule of interest in the given mobile phase, and the second factor that will determine the separation, that is the binding strength of the stationary phase. So these are the two factors which determine the separation of the molecule. Now, binding strength means how strongly your molecule is adsorbed to the surface or to the adsorbate, that will determine its separation. So what we can say, that greater is the binding strength, then the molecules will move slowly, or the rate of elution will be slow, for greater is the binding strength. And if the binding strength is weaker one, then the molecule will move at a faster rate. So this is the case for the binding strength. So stronger is the binding strength, then you can say that the molecule will move slowly. And if weaker is the binding strength, then your molecule, it will move fastly. Now coming to the adsorption chromatography, what are the stationary phases commonly used? The most commonly used stationary phase, they are either a silica or alumina. So silica or alumina, these are the most commonly used stationary phases in the adsorption chromatography. Now, as far as silica and alumina, these two stationary phases are concerned, they should be having a uniform size with higher surface area for the better resolution. Now, the alumina, it may be either acidic, basic or neutral in nature. While if you consider silica, then it is acidic in nature. So whenever you are using either a silica or alumina as a stationary phase, then what is the prerequisite condition? That is, the silica and alumina, it should be having a uniform size with a higher surface area. So in case of adsorption chromatography, the particle size of the stationary phase plays a very important role. Whenever we are studying the fundamental concepts of the chromatography, then we have studied that while studying the column efficiency, that is the efficiency of a column increases with the decrease in the particle size. So that principle is also applicable for the stationary phases. That is, whenever you are dealing with the silica or alumina to use as a stationary phase, so decrease in the particle size of the silica or alumina, it will increase the efficiency, or what we call it as the resolution power. So the stationary phases having a uniform size with a higher surface area, it will increase the resolution. Now, after studying this topic, that is, you have to decrease the particle size and you have to increase the surface area, because increase in the surface area and decrease in the particle size, it will increases the adsorption, because all of you know that adsorption, it is a surface phenomena. So increase in the surface area, it will increase the adsorption, and hence it will increase the resolution power or the resolution. Hence you have to use always a stationary phase of uniform size. Then what will be the probable ratio of the sample to the adsorbent? That is the next point that we are going to study. The ratio of a sample to the adsorbent, it will be either in the proportion 1:10 or 1:20. So the ratio of the sample to the adsorbent, it should be either 1:10, that is, if you are using a 1 part of a sample, then you will go for 10 parts of the adsorbent, or 1:20. That means if you are using a 1 part of a sample, then you will go for 20 parts of the adsorbent. Now, what will be the order of elution in case of sample whenever you are going for the adsorption chromatography? So the order of elution is like that. That is, the next point is the order of elution for sample. it will be non-polar, greater than moderately polar, greater than highly polar or most polar molecule. So this is the order of elution for the samples in the adsorption chromatography. Now coming to our stationary phases again, when you are considering silica, then selenol is the active group present in the silica molecule, and whenever you are considering alumina, then Al3 plus ions, they represent the active sites. So for silica, selenol group, and for alumina, Al3 plus ions. So both these, what they represent? They represent the active sites. Okay, so selenol group is the active site in silica, while Al3 plus ion is the active site in the alumina. Where the active sites play important role? Nearer to the active sites, all the functional groups of the different molecules get attached in case of adsorption chromatography. So all the functional groups, they will try to arrange themselves around the active site. Hence the active sites as well as the functional group, they will play important role in the adsorption chromatography, because whenever you are analyzing any molecule, then every molecule, it has a tendency to attach the functional group towards these active sites. And after this active site and the functional group interaction, you will come to know that is the adsorbate-adsorbent interaction. It is followed by the number of interactions, or what we can say that during the adsorption chromatography, along with the adsorbate-adsorbent interaction, the number of interactions are taking place simultaneously in case of adsorption chromatography. So what are these interactions that are taking place in adsorption chromatography? The first one is the dipole-dipole interaction. The second one is the hydrogen bonding interaction. And the third one is the pi complex bonding interaction. So we have also discussed little bit related to this different number of interactions. All these interactions are carrying out while we are studying the nature of partition forces in the fundamental concepts of the chromatography. Dipole-dipole interaction, as all of you know that whenever the molecule develops with a delta positive as well as a delta negative charge, then that is known as the dipole-dipole interaction. For hydrogen bonding, intermolecular hydrogen bonding and the intramolecular hydrogen bonding, these are the two types of hydrogen bonding. And pi complex bonding interactions, these interactions arises when the molecule has one or several double bond, or what we can say that the presence of lone pair. Whenever there is a presence of double bond or lone pair of electron, then we can say that there is a pi complex bonding interaction. So this is our today's discussion related to the adsorption chromatography, then the interactions between the adsorbate and the adsorbent, and along with that these are the number of interactions that are taking place during the adsorbate-adsorbent interaction, and adsorption chromatography is nothing but the normal phase HPLC. So after this we will discuss about the heliotropic series and the remaining part of this topic in the next lecture. Thank you.